My name is Vikas. I work for a company called Vortex, and she is my business partner, and I've known him for about God knows how long now. So yeah,
Too long.
Essentially, this is something that's been talked about in various different forums. So I thought it might be a good idea to bring it up here as well. And obviously, it had nothing to do with she asking me to do it anyway. Uh, so talking about giants of female, this is Kalpana Chawla. Basically, she was the first Indian-born woman in space. Unfortunately, she passed away when the STS-107 mission crashed during re-entry. But she was an inspiration to a lot of people in India, especially girls, even now in India, whether it's rural or in the urban areas, it's okay, but in the rural areas, you still find the discrepancies that the girls don't get chance to go to schools. So for them, she's been a role model, and she's inspiring everyone to take up science and just get into education. And that's it. So I like the quote there. I never truly thought of being the first or second someone or being a small town girl. This is just something I wanted to do. So that's who she was really. Right, a disclaimer. So what I'm talking about is not magic. So you can't ask Alexa to do your work for you, unfortunately. You'll still need to do the groundwork. So you have to build up the architecture, and you will see the benefits in the long run. So with that in mind, so about Vortex, so like I said, that's Shri, LabVIEW champion architect, and me, everything about without the LabVIEW champion. So we've been doing LabVIEW and TestStand for quite some time now. We've done various different projects around UK, and our basically our background is electronics hardware. We come from electronics, but we've done software for a very long time as well. We do system integration and test. And Shri obviously is involved quite a bit in continuous integration, UML, and we do hardware abstraction layers and usual things really. Coming to the actual presentation now. So what is this about? So this is about writing test sequences using a generic format such as INI or XML. So instead of you having to go into TestStand to write your test sequences, you write it in a text file, which you don't need to know TestStand, anything about TestStand. And then you translate this into a dot sequence. So the advantages of this, or why do we need it? We can let non-coders do the work. So essentially, as architects, we can put up our feet and sit there and let somebody else do the work. Then you can translate the specification documents. So for example, if you have something like doors, you can essentially have these text files indoors. You can do all sorts of things with doors. Obviously, you can do document compare, diff, whatnot. And then when you're actually happy with the structure, happy with your tests, you then convert it into a test sequence. And then when there are hundreds of test cases with common routines, requirements, tracing, it becomes really, really helpful. You can update it and then just quickly go and rerun your converter, and then it gives you a new sequence file. So that's the reason, and mainly how it's done. So we define a standard. We define how we want to structure our XML file, as with everything we do, and then you implement a translator. And the translator you can. So there is TestStand API, which people know about. So you can do all sorts of things with the API. But NI ships a couple of examples with the TestStand, which are already installed when you install TestStand. So we'll go through a couple of them. And there are NI toolkits which you can buy as well for additional cost. So, so just to talk about the built-in TestStand format. So if you look here, if you've seen any test sequence, so if you open a test sequence, so you can actually save it as an XML file, and TestStand already has this option. So it's slower, but it's readable. Somebody can go and actually look at the file. The issue with that is that, so I've only got these two lines of code in there, and you can see the number of lines of XML file it's generated. So it's not very practical, so you can't easily go and edit them. So that's the main reason you want to do something customized. So I've got 3 methods, so let's just go through one by one. So custom XML format. So this is an example that ships with TestStand. So I'm just going to go through that. So yeah, that's where the examples are stored when you install TestStand. So you can just open it up and check. So it's got a bunch of LabVIEW VI. So there is a LabVIEW project there. And essentially what it does is it's got a build specification that converts it into a DLL. And then you install the DLL into the right folder in TestStand and then restart TestStand, and it recognizes the format the next time you open an XML file. So step A rather, so you define the format. So in this instance, it's quite simple really. So you've got 1, 2, 3, 4, 5 tags that you would define for your sequence file, and you've got various different variables that go along with them. Next step, you build the DLL. So if you open up that project, you've got a build specification already in there. So all you have to do is right click and build it. Once you get the DLL, you just dump it into this folder here. So TestStand public components translators, restart TestStand, and then you go into TestStand, you open file. Now, what you will see here is you have this added example XML translator format. So this is what the DLL provides basically. So now you can actually open a test sequence, which is an XML file instead of a .sequence file, and the TestStand automatically converts it for you. And then you save the sequence file as a .seq file, and you're good to go. So you write your test sequences. The next step obviously is, so you've got the same tags which we saw earlier. So you've got the sequence file tag there, you've got the sequence tag, you've got the step group, step. So you essentially start building this up. One thing I did notice when I was looking into this was it's not always obvious what parameters you need to pass when you're creating a step. For example, if you're creating a message pop-up step, you can leave everything else as default and only provide the, like in this instance, you're providing a message expression, but you're not specifically specifying what's the name of the button that it pops up with. But if you go back into TestStand and if you go into pre or post expression, if you do a step dot, you'll see all the properties that you can use. So all you have to do is come back here and then populate them, and it'll show up. So I'll show this when I do the demo a little bit later. So there you go, and then you open the file in TestStand. So as you can see, I've actually opened the .xml file. It's not a .seq file, but TestStand has translated this and it's converted. So it's given me a step there with some parameters, step there with some parameters. And actually, you can go ahead and execute this as normal, and it'll do whatever it needs to do. So let's have a look at how it works. Let's see if this one works very well. Right. So this is the LabVIEW project I was talking about. So I'll just quickly open this. So as you can see, you've got various different functions there which are already built in. So I'll open. So there is one called as translate to sequence file. So you've got some help there, and there is an XML format that's been defined in here. And you've got a few sub VIs which read the XML file and then go on to using the TestStand API to convert it into a test sequence. So you can just right click, build that up. So if you go into the build spec, right click, you build it out. And I've already done that, so I can just go and look at the folder. So build the DLL, and then I've dumped it here in that folder there. So the locations of all these folders are in the presentation, so you can look at it later. So once you've done that, you just restart TestStand. And then, to be honest, you can just do a drag and drop as well. So going here, so there is this XML file there. So as you can see, there's a message pop-up step there with the parameters in there. So I'm just going to take the XML file, dump it there, and there you go, it's generated a sequence file for me. So now, one thing to note is if you try to save this, it will give you an error saying that you can't save it as a .xml, basically. So it says it's been translated, so you have to save it as a different file name. But you just do file save as implement character. Any questions so far?
Yeah, how does the translator would deal with custom step types?
That's a good question. So you can install custom steps. So there is a folder in here where you install custom steps. So you've got a folder called translator step types. So you essentially define your LabVIEW VIs and you define your step types, and then you dump it into the public folder again. So, so yeah, so you've got step types in there, so you can define anything you want and dump it in that folder, and it automatically picks it up. But again, you'll have to make sure you've defined the XML tags for them, and then when it comes to translation, it knows that it has to use that VI and it has to pass those parameters in. So as I said before, there is a bit of work you need to do to define the structure in the first place. And then when you're happy with your DLL, you just write your XML file and it'll do the translation for you.
So you can't all your code modules that you want to include in a sequence that you generate in this way have to go in that specific folder. Is that right? So if you have like project specific ones that you know an XML file for item A that's only used for that particular thing, then how do you sort of dynamically call code modules for unit A?
So for that, there is another method using the ATML toolkit, which does the LabVIEW VI generation as well for you.
Yeah, I mean, I don't need to generate the VIs, but like I might create like have a subsequence that does some stuff specific to that. But it sounds like you have to put all of your code modules in your.
No, it doesn't. It doesn't. I mean, so in the next bit of the presentation, we go through creating. I mean, writing this XML can be error prone. So maybe, yeah, right. So there's no linting that we know of which will allow us to error correct this XML. So what we did was we then did another API on top, which translates the requirements into like properties of properties that TestStand is looking for, and then we feed into the VI that Vikas showed just a couple of minutes ago, and in that sense, then you can say, okay, I have now a VI in my project directory, so you can have a relative path or anything like that. It can be a sequence call or a LabVIEW or a DLL call. So so yeah, this VI here. So we have a little bit more in the presentation.
Yeah. Right. So looking at the second method, so using the LabVIEW API and template sequences. So essentially, the steps remain the same. So you still define the format, you still define how you want to, so I'll go through this anyway. So you define the format, so you adopt a company-wide standard, Sorry, I need to go back and say, so the reason we have having the second option is if you don't want to go through the process of building a DLL and doing it all that way, you can directly use a LabVIEW API and get into the API and do it yourself. So this is essentially that. So you still have to define a format. You still have to define your tags and the parameters and everything. And then you generate template sequences. So this is something slightly different to what we did before. So you generate a template sequence which you can then apply to any subsequent sequences you generate, and then you use the LabVIEW API that we saw earlier. It's the same VI we saw earlier, which was that one, the create sequence file from data VI, and so as you can see here, it's a big structure which essentially goes through. So this is a list of sequences. It's got a cluster with the step groups in there, which has a cluster with steps in there, and you've got property values for each step. So it's a iterative thing. So you just run it through, loop it through, and then you start building up your sequence step at a time. So we saw this VI earlier. So like I said, we iterate over each sequence first, and then iterate over each step group, iterate over each step. And for each step, you essentially create the step and create the property variables for it. And then you generate the test sequences. So in this scenario, we've chosen to use the format as an Excel file instead of an XML file. So essentially, you've got each one of these lines indicating what the converter needs to do. So this is the stage where it is. This is the step. It's a type sequence call. Needs a sequence adapter, and you've got parameters. We've also got some limits here.
So just to answer your question, in the module, can you see that it's a relative path? I mean, so which can then be set when we create the sequence. I mean, so what we've got here is like, I mean, so asking the requirements guy or the test case, the guy who was writing the test case, or guy or girl, is to write it in a particular format that's a company-wide standard, and then which means that you pretty much are writing your test cases, and then that can be translated. So we have a VI which translates this into subproperties of TestStand sequences. And I mean, it's not a complete solution. It won't give you 100% unless you put in a lot of effort to make it 100%. But what we find is that so recently we did a project where we had 200 test cases, but most of them are very similar, but they have different requirement IDs. I mean, and for us to do that manually would have been a nightmare. So we then sort of built this and started tagging the requirements. So which means that the errors were out of the way. I mean, because you would you would definitely copy paste things and then have a traceability issue. So this way it was definitely that we're getting the right thing out. I mean, so we exported a DOS requirements module into an XML format, and then from there we pass that into this properties thing. So yeah, the more discipline you have when you write requirements and also test plans, I mean, the more easier it gets. So,
and also one of the things is if you want to do peer review or if you want to do code review, somebody who wants to do a code review first needs to know how to do it in TestStand, and then they have to click through each step, click through each properties. They have to figure out every single thing, and then they can say pass. It's a very tedious process. I've done it a few times. This is so much easier. I can see what it is. I can see what the requirement it meets. And once everybody's happy with it, you click a button and it generates a sequence. So somebody has to just look at it once and they know any subsequent generations they do are going to meet their requirements. So yes, just to finish this off, so you run the translator, and then, like I said before, you can use template sequences. So you take the template sequence, you make a copy of it, and then you start building your steps and add properties to it. And then and then you insert the sequence file into a new file, and then you have your sequence ready. So you just have to save it there. So this is an example how to do the translation. So you've got, so all you need to build is these three clusters for the three sections in TestStand, this setup, main, and cleanup. And then essentially these three VIs are the same. So you run the three. Sorry, were these the same VIs?
No, they're different for setup, main, and cleanup, but yeah.
Is it close?
Yeah, it is mine. Okay. Sorry about that.
So yeah, so essentially you run the VIs, and then you would have your sequences ready. So this just shows the API behind it, how you can build up your step information. That shows you how to build up your. Sorry, this was. So this is a sequence adapter. So you're building up a step with a sequence adapter. And then you're building up your properties for each of those steps. This is one thing where you had some issues too.
Yeah. So I mean, some of the things that you see there. I mean, so like requirements.links, and it is not very obvious. I mean, I found it difficult to find that property. So the thing that we did then was to create a requirement in a sequence, or like a dummy sequence, and change that into XML, went into the XML, and then saw what that actually means. I mean, so when you start building this up, I mean, there will be things that you can't find. And so we kind of reverse engineered it to make sure what property we were looking for. And then we could build this library up. I mean, so one thing that we'd really like to do is to release this open source, but it's not completely ready. Is this something that would be useful for any of you guys? I mean, so if there was a library, I mean, not the translator.
Yes. Yes.
Open source it, then other people can help fix the holes in it.
Yeah. So yeah, I mean, so this basically adds. I mean, so requirements, for example. I mean, so we have like sub VIs to do so many things. I mean, so if there was a library which did each and everything, and then the translation bit is very specific to your company, which then can be done by you. And once that's done, then the sub properties get generated, and then you do your sequences.
Have a chat with Nancy about making it open source, because I know they are currently working on like a new collaborative space. Don't know, a little bit like GitHub, I guess, but more like really targeted at LabVIEW development. So that might be a good place.
Okay.
It's G Central.
Yes, that's the one.
Okay. Any other questions so far?
Yeah. Quick one.
Sorry.
Is the loop closed? So you generate your XML in your format, you translate it to a sequence. And at that point, you could, in theory, change that sequence and run a test that didn't meet your original requirements if you change that sequence.
Yeah.
Is the loop closed on the report you generate, compare it back against the original requirements? Or could you, in theory, change the sequence intentionally or unintentionally to so that it no longer meets your original requirements?
Can happen. That's where your other tools, source code control, and that sort of tools come into picture.
Do you see a need for? It feels like a nice addition to this somehow that you'd compare your report you're generating to your
run a test and then run each.
Yeah.
So Mattis, who was speaking just before, did a requirements gateway closed looping with Jenkins. I mean, so which means that you can then generate your report and then see what is covered. I mean, so it gives you a coverage report. So that could be expanded to do something. I mean, like that. I mean, so.
But
do you have anything to add?
Right. Yes. I mean, obviously the tool as well, which interfaces requirements gateway with any kind of source continuous integration solution, also is also available. We can also put a link up for that. So, but what was exactly the question again? Sorry.
The question really was just, have you thought about closing the loop on the actual sequence that actually runs the test and comparing the report generated to the original XML that's generated requirements?
Yeah, it would definitely be possible to, basically what Sri said, it would definitely be possible to use like requirements gateway to get out the requirements from doors, and then you could definitely create interface with the framework that Sri and Vikas have been developing to actually generate the sequence from there.
Yeah, it's a nice addition to once we've finished this. I mean, so it would be something that we could sort of look at.
Yeah, I think baby steps, getting this basically done properly is probably the most important thing right now.
Yes. Yeah. So again, this just shows you how the new routine test.
So if we go back, sorry, 1 second. So yeah, as you can, so no, to the numeric one, please. As you can see with the numeric test, I mean, it gets a bit more complex. I mean, but again, once this is done, and you then only have to worry about the measurement cluster that you need to feed, and then the rest of the things. So like this one is a threshold test. I mean, with a low and a high, and if you're using an expression or not, and those kind of things. I mean, so most of it is catered for. I mean, so. But it does get complex. But I think once this is in place and then we fix the bugs, then the translation bit is the only thing that we need to worry about. It's definitely not easy, but it does take time. But it's still worth it, I think. It's not going to put us out of work, I don't think. I mean, it's still.
I was hoping to put my feet up and. Right. So method number 3. So this is something called ATML, so Automatic Test Markup Language. So it's a standard that I have been working on for some time. So it's now an IEEE standard. You can actually go and have a look at the full documentation for it. It's a standardized format, so it can be used for test program sets, portability across companies, departments, doesn't matter. You can generate text-based test reports as well as test sequences. So it just doesn't apply for test sequences, what we've been talking about so far. You can even standardize the reports it generates. Then, essentially it becomes very modular. And I have been invested into it since 2004 because they released the first toolkit in 2009. So I got that reference from this one here. It was actually Anand Jain's presentation, which showed where they were and where they are, sort of thing. And the current version is 2017. There are a few limitations. So it's a fairly new standard. So even though there is a whole load of documentation in that area, it's not readable. It's not a tutorial, essentially. So you have to work out the tags, you have to work out everything yourself. There are a few references at the end of this presentation, which do go through some of them. But the main thing I find is the lack of HTML editors. So ideally, you want something, an editor, so you get XML editors, which look for everything as you're writing the file. So you would really need an HTML editor for something like this. But the advantage of having something like this, compared to anything we've seen before, is this is standardized. So anything custom you define, you have to maintain it. Whereas this one is standardized, it's defined by IEEE. Any changes to it would filter through, and all you have to make sure is you are compliant with a version of that. So that's the advantage of it. And obviously, I provide an HTML toolkit. So you just it does come at a cost. I can't remember the cost, but if you have a Alliance Partner package or something, then it's obviously included with that. So essentially what it does is it installs, so this is in TestStand Windows, so it installs the test description translator. As we saw with the other translator, this is another translator, so it just installs it. And you can choose what version of schema you want to use, and this is important because Otherwise, the example that it does ship but doesn't work. So we'll just have a quick look at it. So you've got some generic settings there. You've got code module settings, whether you want to generate LabVIEW code modules or CVI code modules. And then you can choose what version of schema you want to use. So depending on the schema, you have different schema name and the namespaces it uses. So let's use version 1. And let's just go through the example they have provided. So under toolkits, you've got HTML translator. So there's a translator there. So we'll go to version 1. And then as you can see, there are 2 XML files. So let's just quickly open that. So this is for about, I think this generates a sequence which has about 6 or 7 steps. And you can already see this is much bigger than what we saw earlier when we defined our own standard. But the advantage is this is a standardized format. And we know if there's an update to the standard, HTML toolkit will handle the translations for you. So for that reason, it's worth using this if you can. And you sort of see the similar things. So you've got entry points defined there, which is a main sequence. You've got a few actions. So let's just go and generate that. So again, so there you go. So it's doing the generation in the background. Okay, here we go. Simple as that. So it's defined the parameters for, so as you can see, these are VI calls. So you can select the vector. So for example, there it's just generated a blank LabVIEW with parameters passed in, and you can do whatever you like within the VI to be able to do the action really. So there is an example which basically asks you to go and replace these with some standard pre-written VIs, but I don't think that's for the demo. So there you go. So you've got that sequence there, and then the other thing was, so let's say you've got a sequence already written, and then you've got an update to that sequence file now. So you've done some testing, or there has been change to requirements, and now you want to go and update that. So all you do is you generate a new XML file and then generate the sequence. So that's essentially it. So that's the HTML toolkit for you. Any questions so far?
So I guess, yes. So how do you see this actually, this looks really cool and useful, but what's the sort of workflow? Do you run, so let's say the XML example, or even this one, do you run that XML file, or do you as a separate step generate the sequence file and then deploy and run that, or do you just run the XML? And is there obviously it takes a few seconds for a simple test, but if you open up quite a complex automatically generated sequence, does that take a long time to translate? And
you definitely want to generate the sequence and then source code control that separately, and then just use, because I've not tried this, but in a runtime engine, I don't think it'll be able to do that. Is that right, do you think? It won't be able to.
It won't be able to generate the LabVIEW APIs, definitely.
Yeah.
I mean, so,
So
but
essentially, on
yeah.
a production machine, you wouldn't have a TestStand sequence editor.
Yeah, yeah, sure.
So you would have only runtime license. So in that scenario, you definitely want a sequence file rather than an XML file.
But yeah, so yeah, essentially whoever's writing the stuff that feeds into basically generates that sequence file, and then that's what you then deploy and run on the.
Yes. Yeah, I mean, and also again, like to go back to my point before, it's never complete, or at least we've not got to a point where it's complete.
Yeah.
We've got to a point where it's 70% complete, and the rest of it, I mean, we put labels in. When we can't translate it, we just say, okay, this is the label, this is the requirement ID, change this into an action or a measurement step. So, so there's still work to be done, but I think a lot of the mundane repetitive work can be replaced with something like this.
Yeah.
Just to highlight, I don't know if anybody has noticed, but there is actually a bug with this, I think, because it's put a go-to step in there. And that all that does is it goes to the next step. So I have no idea why it's done that. So I've not gone through the XML file to see if it's an error in the XML file or the translator, but ignore that for now. So other than that, just go back to presentation. I think so, yeah. So there are a few additional resources. So these are two other presentations which sort of touch on the automatic repetitive development and using the API to generate steps in TestStand. That looks at creating a sequence file iteration tool. So let's say you've got 100 sequences and you want to replace one step with a different step instead of having to go through it manually. So that goes through that example there. This is a website where you can get some information for the HTML toolkit. So that's where you can download it from. And there is an editor available, HTML editor. It's called HTML Pad. I'm not sure who's done that, but it is available to buy if somebody, or you can evaluate it, I suppose. But I haven't tried that myself. I don't know what the limitations are with it. But there are things like that starting to appear. So hopefully in the next few years we'll have better support for this. And any questions?
So in that example there, if you'd made a typographical error in the XML file, when you drag it across into TestStand, what is going to happen? Does it just go error and you have to figure out what's wrong, or what help does it give you?
I haven't tried that. I'll be honest.
I think it will give you an error at the line number, and then say there is an error here. So is anybody from NI still online?
I don't think so. I
Okay.
think Anon and Trent have left.
Okay, no problem. All right, okay, so yeah, I was going to ask about if there was a roadmap and things like that, but maybe we can get an offline response.
Thanks very much.
Thank you.